Because we'll do it both ways. I don't want to turn this into Math 60 again. You already survived Algebra 1. So we know the model that we got is y equals, sorry about the green, my black marker is dead and I forgot the refill spool. Is that legible for you guys? You see everything okay on there? All right, so last question was, what happens in 95? And Ashley said, well, we just change the x to a 5 and then go from there. Get the y. But now I've turned the tables on you because I'm a bastard. And I said, how about when y equals 40? What happens then? So I'm telling you to change this guy to 40. And then, this is where that project you turned in last week comes in handy, because it made you solve these kinds of things for x, depending on where x was. Wherever x was, up to quadratics. So what do we do? What do we do here? What do we do? Help me out!
Subtract 33.1.
Why do you do that? Tell me your name again.
Jessica.
Jessica, I was going to guess Jessica. Yes, go ahead, Jessica.
Well, you want to solve for x, so you have to...
Why didn't you divide by 1.05 first, Jessica?
I don't know, I just learned...
Good for you. That's okay. Good for you for just having a gut feeling about it. We know we have to get rid of this before we get rid of this. Because innately, Jessica knows that when this expression was built, that happened first, followed by this. Which means to get rid of it, that has to happen first, followed by that. It's like building with Legos and taking a Lego set apart. The last piece that gets clicked on is the first piece that has to come off if you're taking it back apart. Think about that. Think about when you're changing your brakes in your car, or if you're changing oil in your car, or you're changing a chain on a bike. If you're taking a part off, you lay them out in order. I'm assuming you well, hopefully you do. Maybe you will now. But suppose you're, anybody ever rebuild a hub on a mountain bike wheel or a bike wheel? One of us, two of us. So there's a bunch of parts that have to come off in the correct order. So what you do is you take the first part off, lay it down. Take the bearings out, lay them down. Take the seal, lay it down. Take the nut, then you got this row of parts, right? How do you put them back in? Reverse order. The last thing that came out is the first thing that goes back on. Solving an equation is the exact same thing. It's exactly the same thing. There's no difference. So since the 33.1 went on last, it has to come off first. Thank you, Jessica. Ba-boom, 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 ba-boom. There we go. 6.9 over here. I'm doing my math right. One thing left to do, yes? Becomes one of those equations we had last week. Divide by 1.5. What's it come out to be? 6.5-ish? What do you got?
6.57.
6.57? Cool. We'll call it 6.6, about equal to x. We've got x. Boom. I know, thrilling. I know. You guys, please, Ashley.
Would I have been wrong if I would have put 7 because I just looked at the...
You just rounded it up?
Yeah.
Hold that thought, if you would, Ashley. Now, not to dump your question back, but I'm going to put it down the pipe because we've got a really good answer. Amy said 6.57. I said 6.6. Ashley says 7. All of us rounded to a different... No, it's okay.
Yeah.
It's good. It's good. All of us rounded to a different value. If we answer it in significant figure talk, your answer is correct. And here's why. Here's why. The original numbers that we had were all whole numbers. They had no decimal places, correct? That means we were not really allowed to have decimals, if you think about it, because that's too much precision for the original values. The original values were whole numbers, so our answers based on them shouldn't have any more precision than that. That's the scientific answer. And it's a good one. I like that scientific answer. It makes sense. Scientists made it up for a reason. But I've got a statistical answer that's going to serve us even better as we get through the point. And that's what I want to hold your question until later. My answer is it doesn't matter if we go 6.57, 6.6, or 7.
So it won't be wrong.
No, I have a better answer for us. And it's something that you may have learned at some point in your lives, but you're definitely going to learn it here. But give me like half an hour. We'll get to it. Right now, I'm just worried about getting down to whatever you get, whether it's 6.57, whether it's 6.6, or whether it's 7. Of course, the more important thing is, what the hell does that mean? Whether it's 6.57, whether it's 6.6, or whether it's 7. Let me see hands on this. What does that number mean? So you got this beautiful number. You solved an equation. Yay! We solved an equation. But what does that actually mean? Tell me again.
Ashley.
Ash. There we go. Okay, good. Thank you. Ashley, go!
It's the where x intercepts on the 40 point.
Good for you, sister. So if we take where y equals 40, which we just did, right? This is y. Y equals 40. Ashley's telling us it's where that would intersect the line. It's the x value. Perfect. And I love that. except for you didn't tell me what it meant in context. I love that. I love what you just said, because you just actually gave us another way of solving the equation. You could actually just take your pencil, go up to 40, drag across, then drag down, and figure out where that number is.
That's what I did, and I was gonna ask.
Good for you! Did you use your TI to do it?
Yeah.
Let's come back and do that in like 2 minutes. Because that's the intersect method of doing it. We'll come back to that, I promise. But Amy, what does it mean?
Okay, 6.57 is what I got. Years
Okay, cool.
since 1990, 40 million people under 65 did not have health insurance.
Boom! It gives you the year in which 40 million people were uninsured under age 65. So if you want to get it, and I love the way you said 6.57 years after 1990. You could also say sometime in 1996, that works. Or 1997. We're not allowed to be that precise. I mean, it's tempting to go 6.57. It is tempting to do that, and then figuring out, okay, so that was that June 16th. Exactly.
Yeah, that's how
we
I-
chuckle because you're not allowed to have that much precision, right?
Right.
The original numbers were jumping every 2 years. How dare us then go in and make it on June 16th at noon, no, 12:31 and 12 seconds. That level of precision is impossible based off these numbers. So sometime in 96 or sometime in 97, about 40 million people were uninsured. Beautiful. But the kicker is to have the date in there and also to have the number 40 million in there. That's what I want. And I like the 65, under age 65 uninsured. That's good too. But I'm really picking on making sure you've got these guys in the answer. That's what I really want. Is that fair? Cool. Now, Ashley had another way of getting that number. I did it with my finger on the screen by going up to y equals 40 with my finger and then drawing across. Well, your TI has a finger in that respect. I mean, in so many words, you could actually do what we did with my finger on your TI.